All right, everyone, give me just a second. I want to change my name real quick for the webinar. Real quick, we'll do sales at AFT. There we go. Okay, well, thanks for joining me, everyone who's live at least or watching the recording. Thanks for at least checking out our content after the fact. It's morning here in Colorado, so you may be earlier morning, night, evening, afternoon, who knows. But thanks for joining. So this is going to be the, let's see. Yes, the webinar on leveraging Excel to improve your modeling experience. And apologies for any late start or whatnot. We're just trying to get ourselves organized with the sound check. But I think we're good to go. Again, so webinar on leveraging Excel to improve your modeling experience. My name is Walt. I'm a applications engineer. I do a little bit of everything for the company, not except software development, but I do other things. So anyway, enough about me. Let's go ahead and get started. Excel is a pretty cool thing, especially with it's especially used by engineers, around the world. So that's why we go into this topic. A lot of these concepts, though, could also apply to other programs, like if you do special coding like Python or MATLAB or what have you. The same ideas apply. It's just a different tool, right? But anyway, we're going to go through importing with Excel, right? The basics, and this thing we call the change data import process. And that's going to be an in-depth example where we really show how Excel and Fathom can work together. Excel with the the ability to create formulas and kind of a visual way to program. And then we'll go through exporting, the exact same kind of thing. The in-depth example is going to be with our export manager, but pretty much it's the same but different. But we're going to go through importing and exporting, okay? So let's see. Now let's go through the basics of importing with Excel, right? So the most basic functionality you can do is copy and paste. That's a common thing that you probably will try if you don't know it can do it, but you'll probably try. There'll be a screenshot, of how to do so, and we'll go through a quick example. But it's good for quick updating and creating tables, whether you have the data in Excel ready or not. Like if you don't have the data, that's okay. Because it's a lot easier to type through Excel and navigate through Excel than it is in software or other engineering software, because that's what Excel's good at, right? They are a spreadsheet, or Microsoft, at least one of their products, they're a spreadsheet company. So it's easier to navigate through that. So even if you don't have the data ready, it's typically easier to type it through, right? Paste it in. It's also useful if you want to do math on some of the values. An example would be you have a pump curve and you want to apply your own affinity laws, which by the way Fathom does, but let's say you wanted to do it yourself. You can do that and adjust the pump curve in Excel using math and then copy that table in. And you can also import CSVs into tables, so that's different from an Excel file, but Excel is used to create CSVs. It's like copying and paste, but more formal. Like you actually tell Fathom to import this CSV with whatever separating character you have, if you want to include headers or not. And this is useful if you have the data ready in a CSV and you just want to call it up without having to open it again. So here's what it looks like I keep talking about this from the perspective of Fathom, but all of this applies to every software product we have: Fathom, Aero, Impulse, Extreme. I'm doing Fathom because it's it was our first product, but it's also the most common product, incompressible flow. So anyway, I'm going to be talking and showing examples from Fathom, but if you use any other product, it's the same thing. It's just maybe components are different and all that, right? So here we have an example of a CV curve that you can enter in a valve. And this is a table that you can either type manually or use Excel, like I said, to copy and paste. So if you copy your table in Excel, you can click in this top left corner, paste it, and it'll propagate through. Or here was that other thing you can do, which is go to edit table, import from file, you can bring in your CSV. And here's a similar example with a pump curve table. So what I'm showing here is that most, if not all, tables in AFT software have this functionality where you can paste in or you can edit table. The button location might be different, but that button should still be there nonetheless, where you can import manually. So let's go ahead and bring up the example. So here is a Fathom example. We're going to take this through our webinar today, kind of going from a beginning model to, wow, we did pretty in-depth, analysis using Excel with not too much time spent. So what we have here is it's pretty much a cooling water system, but a cooling water system that can have various operations, and we're pulling this water from a lake is my idea. So this whole process unit, let's call it, has need for water, and you will have various valve positions and directions and all of that. So that's kind of the story behind this model. It's just an example. So here we have a control valve, FCV being flow control valve. I can open this up, go to optional to create my open percent versus CV. So if you know anything about valves, it's really about valve positioning with its flow coefficient. How is it controlling flow? Another thing, I guess this brings me to another point that I forgot to mention, is I will be moving quickly. And I assume that you at least have a pretty good understanding of our software. If you've never used our software, then this webinar will be useful for knowing like what things are possible, but you won't really be able to do it because you haven't got the basics down. If you're looking for that, I highly recommend our other materials on getting started with our software from the basics. So I'm going to be kind of moving quickly through these junctions and all of that, just FYI. So we have this, so we have this control valve, and I want to put in our table, right? So it's actually just as simple as, let me find the spreadsheet, taking a pre-populated or entered, or maybe you got this from a vendor, who knows, open percent versus CV that is in the form that you need for Fathom, which is that you're matching, your X and Y line here, open percent versus CV. So what I did was I control C in Excel, and now control V here, and bada bing, bada boom. Now we have a CV versus open percent curve from 0 to 100, ranging from CV to 700. And what this allows us to do now in a bigger picture, kind of unrelated to Excel, is, well, now this flow control valve will meet its set point of, this flow rate of 750 GPM. I will be working in God-given units today. That is the imperial unit system. Anyway, it'll control the flow, and then output will tell me, oh, this is how open your valve is. It's an open percent output. So that is what this curve is useful for, just FYI. Oh, cool. Bada bing, bada boom. We'll do a similar thing with a pump curve. We're working with centrifugal pumps here, but instead of copying and pasting, I'm going to import. So remember, there's always this little drop down of edit table. I'm going to import from file, and I'm going to go to my Excel books area. And remember, it has to be a CSV. So if you have something in Excel, you can just save it as a CSV. Pump curve, boom. And I will say ignore the first line, because if you're curious, this is what the pump curve looks like in Excel. I have purposefully matched flow on the left, then head, then MPSH, then efficiency, mapping out the units so that I know it correctly gets put into Fathom, okay? But this contains headers, and that's why this question is being asked. Do you want to ignore the first line? And the answer is yes, because the first line is just a text, just a string. I say, okie dokie, oh, cool, puts in my data. A pump curve, maybe you have this from a supplier ready to go as a CSV again. It's just up to you what is faster for you to type all this out or to have a CSV you can call up later. But I'm going to do an interpolation actually for this pump, say, okay, cool. So it got me MPSH, efficiency, all of that. And I'll do the exact same with this other pump. It's actually the same pump curve, but instead of importing, again, you can't see me, but on the other screen, I'm copying this table and I'm pasting that bad boy right in there. Again, gonna make it interpolation, linear interpolation between the points, and this is my pump curve. Boom. The alternative to what I just did was, well, I could copy data from the other pump, but I'm just showing you how Excel works. Cool. All right, now we can run it. Neat. We get output, things work. hopefully, because I prepped this model for the webinar. So that's one form of importing. Another form is with this. This is a kind of a bigger project. So I want you to kind of step away from the idea of just like a quick copy, paste, quick import. This is now, you have to have strategy when you're thinking about importing with Excel change data, because it's a bigger thing, and this will make more sense as we go through it. So this is a way you can import data about your components and pipes with a spreadsheet all at once. So you can change a valve position and then change a pump speed all at once with this change data spreadsheet. But it's change because it cannot draw a model for you. There is no coordinate system. It doesn't know how to draw your workspace or what items are connected. So you have to build the model, then put in initial input, and then use Excel to change it. That's why it's called change data, if you're curious. This is very useful if you want to make mass updates. That's across multiple components, but those updates are not the same across components. So if you're familiar with our software, you know about Global Edit. Global Edit is excellent for mass updating components if it's all the same value. Example being, you want to change your header pipe sizes from 10-inch all to be 12-inch. You'd use Global Edit because it's one step essentially to change all of these pipes to the same value. But what if instead all of these pipes were not supposed to be 12 inches, they're all individual? Well, that's where importing Excel change data is useful. It's good for mass updating components of different values and mass updating many types of components. So Global Edit is good for the same type of component for the same value. It's quick, it's easy, it's beautiful, I love it. But there are times where you need to do mass updating, but it's not all the same component and they don't all have the same value. That's what importing is for. So an example is, oh, well, this valve is 20% open. This valve is 45% open. My supply pressure is actually 15 PSI. That's oh, little typo, not SPIG, but PSIG. Yeah, God-given units, okay. And then pump one, right? So you can do all of this at once with a spreadsheet, but it takes a little bit of an investment, and we'll show you that. But it's an investment that pays off. The way you do this is you prep the spreadsheet. Well, you might ask, well, what are you talking about? Okay, there is a template spreadsheet you need to have access to so that Fathom can read it appropriately. Meaning we, AFT, and our developers created this template specifically so Fathom and Arrow, whatever software you're in, can read it. So you need to use the template. The template is found in the default installation area, which at least the time of this webinar is going to be in your Windows C drive, AFT products, and then whatever software you're in. So I'm in Fathom 12 right now. It could be Arrow 9 or what have you. This is also available for more later versions. So if you're working in an older version, this might not be available. I can't remember specific versions off the top of my head, but this assumes a fairly newer, within the past few versions. You'll find this spreadsheet. You want to copy it to another location so that this remains intact. You never want to change the original copy, right? Make a copy, then change it. And when you enter all your stuff, which I'll show you what that looks like, you go to File, Import Change Data. Boom, simple as that. It'll read all your information, make all of the mass updates, and such. So let me show you what the workbook looks like, or the spreadsheet. Here we go. So that template I showed you in that directory, right, that's installed with your software, looks like this when you open it. There's a lot of instructions on the side and notes, and these are good, but I'm not going to go through each one of them. We also have an awesome help guide help guide topic on Excel. Let's see, Excel importing. If you go to our online help, you can type in Excel importing. You'll see. Anyway, so it'll give you instructions. What we're looking at is, do we want to apply the change? Yes or no? Most of the time it's yes, but you do have the option to like toggle it on and off if in one import you want to change something, another import you want to do something different. You choose what kind of object. So you see these little arrows, that means there's predefined things in here, which is why it's important to use the template. Then you need to put in your object number. The number, the ID number here, let me open up Fathom again, is this number, the junction ID. That is how AFT software maps things and decides connectivity and all that, is with the number, not the name. So you need to put in the number, the ID number. Okay, where are we at? I'm just gonna minimize this, there we go. You choose what you wanna change. Do you wanna set it equal to, or do you wanna change by some value? But in our examples, we're just gonna set everything equal to, you know, whatever value we're looking at. You see, this is just a number. Well, this kind of requires you to know what units your original model was in, because you're not importing units, you're importing a number. So hopefully, you know, if this is feet in your model, you understand that 88 here means 88 feet, right? You want them to match. So again, in our in-depth example, we'll show the importance of map, or like how I will note all of those to make sure everything's clean. And you can do this with any type of object that exists in the software, and most parameters, not every parameter, but a good amount. So it also has some formatting stuff, like if instead I do a screen, oh, well, now that I'm looking at a screen, the parameter of fixed speed doesn't make sense anymore, right? That's not with the screen. So it's red, it's like, hey, something's wrong. So instead, oh, I'll probably choose my K factor actually to -5. That's, well, change by value -5. Maybe that's because it was at 15 or something. But you can always, you know, change this to set equal to value 10. Okay. So you go through this, you can go through this manually, just because that's the most straightforward. You choose what you're doing, which one of them you're doing, what you're changing, all of that, okay? And then you import it. So what I did, let me get this one up, is I took that same spreadsheet, made a copy, and I entered in the actual important, or the information I want to change for our model. So let me pull up our model. I am going to minimize this so I can split my screen. Oh yes, there's a lot. Okay, I think it is, it's a problem with doing a webinar with Excel, it's too many things. All right, too many Excel books open. No, I'm just kidding. All right, so in this case, I want to change some of my control valve set points. So these guys down here, this guy up here, I know these are flow control valves. So when I'm reporting 800, that means it's in gallons per minute. Right now it's at 750 gallons per minute. I want to change it to 800 gallons. Oh, this other one though, this third guy here is, again, it's just a number, but I need to know what is that number. This one's not a flow control valve. This is actually a back pressure valve, or a what we call a pressure sustaining valve, where it controls the upstream pressure. Right now it's at 33. I want to control it to 35. I want to make sure there's enough pressure back here. So again, that's like the importance of knowing what valve you're changing, what are the initial inputs, okay? Then we have a couple of these more manual valves. That's what I'm calling these MVs. And I'm changing some of their open percentages to be like this one was 50, I want it to be 55. This one up here, this one's 55, I want it to become 60, just as examples. This is not something I expect you just to be able to reproduce, because I had this prepped, and in order for me to make this, I had to go through line by line, right? But this is just showing you the spreadsheet and what you're able to do with it. There are special, and okay, pumps are the other ones that are pretty normal, which is, oh, they're operating at 100% speed. I want them to actually operate at 95 in my test case. Let's just see. Okay, for whatever reason we're doing this. The not so straightforward thing is when you have a special condition. So what I want to do is I want to close this valve essentially, but Fathom does not allow you to just enter a CV of 0. It needs to be positive. The way to close a valve actually is with a special condition called closed. That's the only way you can really have no flow through it. So in the spreadsheet, it's not actually open percentage equals 0, it's special condition equals, and we have codes for things that are radial options. The special condition of 1 for a valve means that it's going to be closed. And we have that in our help file, and I'll show you that here in a sec. But again, the special condition is kind of one of those unique things. So cool, I have this saved. I don't need to put in a scenario name because, first of all, I only have one scenario, but I'm going to import while I'm in the scenario. So let's do that. So file, okay, import change data, Excel books, boom, Excel change data. That's the one I haven't changed it. And what you should see is, oh, 11 changes were made. It copied the correct rows. Hopefully that matches with our 11. And it's like, oh yeah, I have 11 components here and I have 11 here. Things probably look good. And I could go, oh, look at that. That valve now is closed. Still has the 5% open, but special condition closed, right? So now my changes have been made successfully. My pumps are now operating at 95% speed. So that change worked, which is always good, especially when you're giving a webinar. All right. Now let's do something a little more fun. Let's see. I think this is where I want to go. Yeah. So what is it? So that's cool. That's 11 components. You know, maybe for you, it's like, why would I go through and make that spreadsheet when I can just change them? And you know what? You're right. It depends on how much you're doing. That's just to show you what kind of thing it does. But you can imagine when you're updating 200 components, then yes, using a spreadsheet is going to be much better. But not just that, this slide here, it can import across several scenarios at once. So you can do, hey, this scenario, update these 20 components. The next scenario, update the same 20 components or different ones or what have you. And you can mass update many components across many scenarios. And when you're working with a lot of data like that, then having an automated process makes makes everything smoother. Oh, what if you have to make a change or what have you, right? Just a reminder, there's a limit to what parameters. Most parameters are available, but not everything you can update about a junction or a pipe is in that spreadsheet. But here's that help guide that I mentioned. So when you have questions, this help guide is amazing, I will say, especially because it's searchable. So we just hopped right on that link, docs.aft.com, Excel import, boom, enter. Boom, importing from Excel, it has that. And here is where I talked about when it's kind of a weird case of like, you're not putting in an actual value, you're putting in a code. This is where you can find the codes. So the valve special condition closed means I put in a 1, which is why we went through that in the spreadsheet. So now kind of having a big picture understanding of importing with Excel, let's try that. Oh, I want to change across multiple scenarios, right? So right now I'm in 1. What if I wanted to test 12 different cases of all different valve positions and pump speeds and whatnot? What I can do is I can generate 12 children scenarios, name them whatever I want. They will each be carbon copies of the parent. So again, this is why it's important to have a background of Fathom to understand this webinar, as you can create scenarios. But I would create a child of like case 1, right? And then create a child case 2, however many I want. And I can name them whatever. They're all going to be the exact same copies. And I will use Excel to update each scenario and each component positioning, essentially. So let me pull that up. Oh, there is my spreadsheet, and here is what it looks like after I already made all of the 12 cases. So again, I did this in preparation, but you can imagine all I did was right-click, create scenario 12 times, naming these things because I wanted to give them descriptive names instead of just case 1, case 2, which you're more than welcome to do. It's just maybe it's not as insightful or easy to read for making reports and all of that. So what I want to do is I want to change multiple scenarios at once, change all the components, but I need to, as the user, I need to decide what is different about each one of these scenarios, right? Each one of these has different valve positioning, all that, okay? So the best way typically to map those out for yourself would be like a table. And funny enough, we're in an Excel webinar, so I made an Excel table, mapping out all of the different things. So there's a lot to look at in this table, but I want to bring your attention to the blue area. Here is where each column represents a different scenario. Okay, scenario like 1, 2, 3, all the way through 12, but here are the actual names. And these names have to be the exact same, by the way, when we're using formulas that'll come up later. But in any case, each one of these is a scenario, and each one of these are the same 11 components I showed you before, but across different scenarios with different set points. So in scenario 2, I'm changing my control set point, and I'm changing what my bypass valve is there. So I'm taking the same 11 components, but changing them across 12 scenarios. So what does that mean? How many entries in my Excel import change spreadsheet will I have? I will have 132. So if I highlight this, 11 by 12 is 132. You can even see Excel tells you it's 132. So if I go back to this spreadsheet, which was what we already imported with, remember, each line is specific to one component for one scenario. So I will need 132 lines, all mapped correctly with the correct object number and correct set points. And one way I could do that is pretty much take this and copy it 11 more times, right? But then manually change these numbers, which again, it depends on how much data you're dealing with. But for me, if I'm dealing with more than 100 rows, I don't trust myself enough to even let my eyes catch this and figure out, oh, this is supposed to be 700, 700. And then you also have to map the scenario path name, of course, because now we're dealing across different scenarios. But this gets cumbersome. And the beauty of Excel is not only that it can be faster, it depends on how much data you're dealing with, right? But the more data you have, the more of a relative benefit you have from Excel. But the biggest thing, probably my argument, is that you can trust it more. Because when you're using formulas and logic and letting the computer put in things appropriately, rather than you typing, oh, whoops, this one I put 750 or what have you. Doing things manually is not trustworthy. Like, you're gonna make a mistake, and using Excel kind of ensures you're not going to do that. So what I'm trying to do is, sorry, I'm bringing back this spreadsheet. I want to take the idea of the same components but different configuration for each scenario and have an automatic way to fill out this table, the actual change table I need to enter into Fathom or other software. Figure out a way to get those 132 rows without painstaking manual effort. It does require an investment, but again, with formulas, you can trust it more. So when you know what you need to put in, like where you're going, I know pretty much what it looks like is I have 11 components here, and I need to take the rest of the table, instead of making it like a 2D table, I need to make it a 1D list. But that's not pleasing to the eye, and I don't want to do things manually, so there are creative ways to go about it. With what I'm about to do, I want to emphasize, you are not going to be able to reproduce this because I'm moving quickly. Instead, I want to show you that how you can get creative with your Excel knowledge. The more you know Excel, obviously, the better you're going to be able to use it with Fathom. But you can use your knowledge to do amazing things with Fathom that would take you otherwise hours and cost you further hours because you're probably making mistakes. So you're not going to quite I'm not going to teach you every formula, is what I mean. I'm going to kind of give you an overview of what's happening, but I'm not going to teach you the formulas. That's going to be on your own time, but it hopefully opens up the door for what you want to do, or or what you can do. So what I know is I need to know if I want to apply it. I need to know my object type, my ID number, right? All of the same fields we saw in the other spreadsheet. But I want to pull these automatically updating the scenarios and all of that. So the first thing to notice and to consider when working in engineering is, and with Fathom, you don't know the object number. Almost guaranteed, you're staring at this and where's junction 11, right? I know where it's at. You know, in a small model, it's okay. But when you're dealing with a huge model, you don't always know the ID number. Typically what you know is the component name from a PNID or other engineering drawings. So I'm going to take that approach. I'm going to assume I do not know my object IDs. That's hard for me to know, but I do know my object names. So that's what's highlighted in green here. Is I know my flow control valves, my back pressure valve, my ball valve coming back for recycle. Like I know these things. Also, by the way, this is just a made up example, so I don't expect you to know what these mean really. These are just component names, for example. So I know these, and it's like the first thing I'm concerned about is the only way I'm even going to be able to touch Excel import is if I know the ID numbers that map to it. So there's a good, you can map things automatically in Excel. That's beautiful. What I did was I pulled a copy of all junction names and numbers from Fathom. And the way you can do that is if you, I think I can go back into this one, look at output. Oh, I can actually run it. I can run it. If I run it first, which you have to do with importing anyways, is you have to have a model that works, or at least a model with input. And I just literally copied Control C this table, pasted it here with better formatting. And what it did was it preps my mapping of my component name with a junction number with an ID, right? So you might as well just call this ID or something or what have you. And you can use Excel formulas to automatically map this component name, find it in this list and pull its respective ID. And I can do that again automatically for each one of these components. And this, again, can't emphasize enough. When you do something like this, and you can, I mean, of course, it requires you to know the formula is correct. You can trust this more than me typing this in it, right? Like it's going to match. And it also requires that the names in Fathom are the exact names in your spreadsheet, but that should be a given when you're, hopefully, if you're organized well, names match exactly, right? Cool, so that's kind of the first hurdle to get over. And so the next thing is, this is a matrix, and I need to be able to locate a specific value, which means a specific row and a specific column, right? So what I did is I've just created numbers as sort of an index in place. Again, I don't expect you to reproduce this, but I'm just kind of showing you what's possible. And the reason I know to do this in advance is because I can foresee that this is a 2D table. I'm going to need to be able to tell Excel, look in column 3, row 5, right, for this number. So I prepped that beforehand, made sure all my scenario names were exactly matching my Fathom scenario names and all of this. And what I did here was I know what component it is. So I said this is a control valve, and a pump. In a similar way, well, you probably do the same kind of mapping. This one's a little easier, so I just typed it in. It's important that that matches the spelling of the drop-down menus exactly. So control valve, and pump, okay? I know what parameters I'm changing, which for control valves, I'm changing my set points through the scenarios, sometimes flow, sometimes pressure. I am, for my valves, I'm changing open percent, and you can probably foresee, hey, Walt, you have open percents of 0 in here, and we just went through an example where that's not okay, and you would be right. And I'll show you again, Excel, you can do conditional statements, right? You can use the logic of Excel to get over that. And then we have fixed speed for pumps. So like I've got pretty much the basics of what I need for my spreadsheet filled out. So what I want to do though, again, I need 132 rows, right? So what I'm going to do is map a row and column index to each one of my rows. So what I did was I created a formula such that it will repeat. Oh, I need to pull it down because it doesn't have anything to reference. 1 through 11, 12 times. Just because I pulled it down that far, I knew where to end. But this formula is just telling it to repeat 1 through 11 because those are our component numbers, right? Now I want to do my column numbers, which it's not going to go 1, 2, 3. Instead, it's going to be 1 all the way through 11, then be 2. So again, another formula to do that. And this way, this is a unique location in the table for each one of my entries, because again, this is less like a 2D table and more like a 1D list that I need, I need to map each one of those, pretty much turning this matrix into a single list, right? Cool. Now I'm going to use my component name for mapping these other fields, because again, I need to do this Excel import based on number, not name, but I only know name. So I'm going to similarly put down a component name for each one of my components and scenarios, all 132. And what I'm doing again is one of those map, find this number in this list and report back to me the name. So it's again another formula, mapping now based on the index number, just a way to pull the component names. And you can see, of course, they repeat every 11 as expected, something you could do manually, but if you have 300 of them, again, using formulas makes things cleaner. Now, I want to apply all of them. So that's not a formula. I know my change code is always going to be set equal to. That's not a formula. Those are going to be constant. What our formulas are, tell me what type. Again, now we're mapping based on the component name to tell me the component. Okay, we're doing the same with the number, right? Match the component name to an object number. Match scenario name. Now we're looking at the column index. So that's the horizontal line. Index 1, tell me the scenario name. So on when it comes down to scenario 2, that should pull in a new scenario name. All pretty, again, I can't teach you everything, but these are the basics. The most interesting thing is this conditional statement, right? Where sometimes my parameter is open %, but sometimes it's special condition for valves when I want them to be fully closed. So you can actually use conditional statements in Excel, like with ifs. And if, I guess what I did on this side was I'm pulling my real values from the table. So I'll just drag that down before. These are the actual, like what my table would say. My table says 0 open %, but Excel or Fathom won't like that. So what I'm doing now is conditional statement based on, hey, if this is reading 0, then actually change my parameter to special condition instead of whatever it's reading here. And then similarly with the value conditionally, if that's reading 0 or other things, that's what this represents, then put in the appropriate code for special conditions, which is 0, 1, or 2, all of that. I'm going incredibly fast, so again, not really expecting you to follow or reproduce, but maybe follow along a little bit. You can leverage Excel. Now I just drag this guy down 132 rows, and I've got everything I need, everything I could ever ask for. I'm changing my valves, changing my stuff across 12 scenarios each, so you can kind of see how this relates to these column indexes and all that. All I have to do now is highlight this part of the table, Control C, and I will put it into my another actual copy of the template. This was just my own spreadsheet, kind of pulled with other information to get it ready. Now that I had it ready, I can come in here and paste as values, and it will leave the template set points. It'll match, because my words exact matchly. Excel, this import template has no problem with me pasting in. Now all I got to do is save this bad boy, go back into Fathom, and say, Fathom, import this one across 12 scenarios and 132 times. And you will actually get a message that says it was all successful, good to go. It takes maybe about a minute, but there's no need for us to sit and watch me do it. So I have already done it in another spreadsheet, but I can assure you it did work. And something else that's kind of cool is this. So this is the one that hadn't had it applied yet. I can confirm that by going to a scenario comparison tool. Say all, oh, okay, I need to redo that, sorry. Likes to pull it on my other screen. Okay, show comparison. Only show differences. Boom, no differences across all 12 scenarios. Okay, neat, cool stuff. This one though, where I did actually import everything, see mass import after, so you know, good to name things logically. Okay, compare all scenarios, and what do you see that is different? Only the 11 components I talked about, but each one now has a different value, and you kind of create this matrix. Neat. And you can you go in, let's just look at, recycle open and see what that looks like. Oh, I've opened my recycle path here, but I've closed off all of my tanks. Like, these are different conditions. And the reason I even want to do this in the first place is because there's certain output I am curious about across 12 scenarios, such as, what is my pump performance across all of these different operating conditions? What are my control valve open percentages? Are they failing? Doing multiple scenarios allows you to get insight into like different operating conditions. Cool. Cool, that was fast, but hopefully again shows you kind of the power Excel can bring. Now we're going to go to the other side. Don't worry, most of the webinar was about that import process because it's so, well, that's a little more of an investment. So with that, there's an investment, but now that I have that spreadsheet, I can add scenarios to that, to my, to my table, and really, really easily bring that into import Excel again. If I add 3 more scenarios, or it turns out I want to change 14 components and not 11. That's the beauty of this investment. The output with Excel is kind of a less of an investment, but still requires some setup. So anyway, it's not going to be as long. We can copy and paste from tables into Excel, the exact opposite of what I talked about with bringing from Excel into AFT, go from AFT into Excel. And in fact, I already showed you that when I pulled in the junction information to map, but I'll show you again, right? You can just highlight parts of a table and copy them into Excel. That's good for quick one-time analyses. Maybe you just want to make a report on your one scenario, but you want to filter things, or maybe create a graph, or just format it differently, right? You can more formally export output as an Excel file or a CSV, which most of the time is opened with Excel, but you can export the output, which this is not as customizable. It pretty much creates a spreadsheet copy of your output window. So it's only as customizable as like the output window itself, such as you can put in, your own units, but you don't get to choose where tables go. You don't get to choose what values to show on the export. So if I bring that up, well, I guess I'll show you the screenshot real quick. So one, you can just highlight the corner of a table and it'll copy over the entire table. Or you can highlight just a column, it'll bring over the column. Highlight a row, it'll bring over the row. What I'm showing here is the more what I call formal export of data. So that's export output. You kind of decide what to choose, but each one of these corresponds to a tab in the output window. And then you say export, cool. So I think I'll probably go to this one. So again, I copied the junction. Let me just bring up an Excel file. I'll bring up this one just so we can, yeah. I'll bring it over after I copy it. But remember, I touch the corner, copy, and then paste. And I put it in the spreadsheet, but clearly there's a problem because this is a template spreadsheet, but you get the point. Okay, I've got a junction name, all of these parameters from the table. I'm gonna Control Z that so I don't mess it up. But I can copy and paste, right? Same with values, just single columns, and I can do that with rows. But I mean, that's pretty easy, and it's kind of something you expect. So even if you didn't know Fathom could do that, you probably are curious and tried it anyway. If I go to File, Export Output, this is the pretty much spreadsheet copy of everything. So you can see, oh, it brings out warning tab, it brings out pump summary tab. It's just a spreadsheet copy of this. And what it looks like is this, where each tab in Fathom is just another tab in the spreadsheet. So it's not as customizable, but it gets you your output in something maybe you want to mess with a little more, right? So here's again, that valve and pump summary corresponds to valve and pump summary up here. Pretty basic, not very customizable. Where we're gonna go in depth is the Excel Export Manager, which is different than that export output option. It's different. This is a very specific thing. This is something you open up, it's a manager, and these settings in the manager are saved for your custom export. They're saved with the model. So you can recall it later. You can apply it to many scenarios. You can make changes to it, right? But it's saved. Like the import process, there's upfront investment in setting it up, but there's a big payoff if you're dealing with a lot of data or a lot of scenarios and a lot of things you want to look at. And it exists for the future should any changes be made. So this is the nice thing about like setting some process up is in the future it becomes much easier and especially because model building is an iterative process. So you do your mass Excel import and you realize, crud, something was actually a little different. I can promise you it's a lot easier to change it in a spreadsheet with formulas than it is to, let me go redo 130 data entries, right? So anyway, I'm just trying to emphasize the value Excel brings. A very, very nice thing is you can combine it with batch run to run multiple scenarios and export output after each run to a single spreadsheet that then you can create into a summary sheet that you look at all of the your custom output of various scenarios, and you can look at things, how you want to. Okay. Here is what it looks like, and I will go through that quick in Fathom. So here's my, again, we're kind of starting at the basics right now. If you go to File, you saw that Export Output. Well, just above it, and it's kind of confusing, I understand, but there's the Export Manager. That's different. Because export output 2 is a little more generic, like you can just do a CSV or, I guess make it even more like a text style of output if you just do a space or tab or what have you, file, or it's just values, comma, values, space, values, what have you. Excel is very particular to create an Excel workbook. When you're in output, or really, I think anywhere actually this icon shows, but there's either in File, Export Manager, or this button right here, Excel Export. I can open it, and that's not all, folks. I don't just have to, that's not all I can do. I can add things to it. But it can be daunting to look at first, but when you step by step, it's not too bad, actually. This allows me to create, to choose custom output to put wherever I want in a spreadsheet. So this is like a dummy spreadsheet. It's just pulled up as an example. And I can have formulas ready off to the side to do whatever special things you want to do, right? So we'll get there, but we'll start with first, what do we want to export? I want to export either a single value, a column of a table, a row of a table, the whole table, a graph, or other. So in this example, I want to export a single value. I'm going to say from my valve summary table, which again maps to up here, of this control valve, I want to see its open percentage in the units percent in the first default sheet. Usually you want to change that starting in the cell A1 to C1. So it's starting in the very up left corner. If I wanted to change this to C2, it will automatically update where it ends. Okay, this is a single value, but it takes up 3 cells because it has a header, which means the name and what you're looking at, the value itself, like the actual number, and then the units. And you can see a little example of what I mean, where it's the header, the value, the units. So it takes up 3 cells. And then you do this again with a single value or a table. You want to do a whole table, do the whole valve summary, but start it probably not where it's going to overlap. So if I do like A2, it gives me a little warning. That's not going to work, my dude. So I'll change it to A6. Let's say that. Cool. So it gives you a little preview of what it looks like. Now you can do this, you have to repeat it, for whatever 20 things you want to look at. But once it's set up, you can batch run this and export all of the output across all of scenarios at once. And it is a beautiful thing. So again, this is where it requires some investment, but it's depending on what you're dealing with, which I have personal experience with this, depending on how much data you're working with, this is a godsend. And it truly is when you're dealing with a lot. So that's really the intro to choosing what you want in Export Manager. This is the preview. Now down here is you get to choose where it goes. You want to create a new workbook where Fathom just kind of calls up a new blank instance of Excel. Do you want to put this in a previously saved workbook? You could choose what workbook, or open. So you can see I have a bunch of spreadsheets open because this is a spreadsheet webinar. But anyway, you can choose where it goes and it'll just add on as a new sheet. You can change the name of the sheet. If I say hello, what it's going to do is recognize, oh, there's a sheet called hello and a sheet called sheet 1. And there you go. Now you got them on 2 different sheets. That's just also a little insight. You can play. The best way to learn this is play with it. You can ask me all day, well, can you do this? What if that? And it's like, well, maybe you can. I am not the first to admit that I don't know all of the ins and outs of everything about Fathom and Excel. A lot of it's about curiosity and driven by projects and what is required. Oh, can it do that? So I encourage you to experiment just like I would with my project. Now let's get into a more real example of how I use this though, how to use this. Let's go back to this is the model we left with that is the most updated. It has had scenarios created, it had mass imports with Excel change data. Now I actually want to look at stuff, right? I don't want to just import, I want to export. That's like the point of Fathom. So what I can do, and I look, okay, actually I'm going to go to my base scenario because that's where I set up. It's important to set up your Excel at base so that it propagates downward. It is a global thing, but each of these check boxes is what's propagated through. Anyway, best to do things in the base scenario if you want it to propagate through. And here in this example, I have pre-built. I want to look at my pump. How is the power doing in different scenarios? How's the head rise? How's my velocity in this pipe here? I know because sometimes it gets really high. What are my open percentages of the valve? So like, it's I didn't mean for this to happen, but I happen to be exporting 11 components and I also imported 11 components, but they are completely different. So whatever I imported, get that out of your mind other than that changed stuff. And now I want to look at output of different things, right? I want to look at different things. It just happens to be 11. I can look at whatever I want. It just whatever happened to be 11. So I want to look at all of these things. I set it up. I want to create a new workbook so that upon my batch run, it'll just create a new workbook of separate tabs. The beauty of Fathom with its scenarios is batch run. So if you don't even know batch run exists, regardless of Excel, learn it. You can create all your scenarios and then run them sequentially. So what I would do is I would add scenarios. Okay, I want to look at all of them except my base. I'm actually only curious about comparing these 12. Say okay, and then during its running process, it will automatically export to Excel each scenario as a different tab on a single workbook. So what this means, save scenarios to separate sheets, means in Excel, wherever we are, it'll make one workbook, but it'll create different sheets, right, for each scenario. So just a quick explanation of what that means. And then I say start run. This takes about, I think, 1 minute to run all 12 scenarios, but I'm not going to force you to watch it. What it looks like is it just runs and then exports, runs and exports, and you get a little report afterward. But here's the ultimate result. Pretend I said, yes, start run. Cool, does the stuff. And then this spreadsheet comes up. And it's like, oh, cool. It gives me a lot of info, but don't get overwhelmed. It's just basic info about what scenarios. This is probably the most important line. Oh, whoops. Right here, there were no errors to report. Usually a good thing, but always good to spot check, look at things. Okay, so here are each one of my scenarios, right? Well, what I want to do is summarize all of those on one sheet, on a summary sheet. So what I would do is do summary. I create my own, right? And mind you, this actually is an Excel book, not a CSV. So you can do formulas and save it and it won't get rid of it. So I want to create a summary sheet. This is where now me as a user, I decide what I want to do. I want to summarize all of these things. And I can do so with formulas, calling to each one of these sheets. Like an example Excel tool is you can actually, there's a formula to call out each one of these 12 tabs. So like, because you can see the scenario name was way too long that Excel doesn't accept it as a sheet name. So it created dots. So like there's an Excel function to just to pull the names of each of the sheets in the spreadsheet, okay? Anyway, you can use Excel like that and then ultimately end up with something like this that I made, which is a carbon copy of what you just saw, just I did a little more math and stuff up front. So what we have is through formulas, I am pulling from each of my 12 sheets the various output, and then I'm graphing that output because I don't know, why not? Graphs are cool. It makes it look like it's kind of a something running with time, but that's not the point. It's just each one of these is a case number. But I guess you kind of use this like a transient solver. Each scenario, is one of its own case, and track it through time. But anyway, what I'm looking at now is now that I summarized all of my stuff from my output, I'm looking at my pump. How does my pump power behave through each of my 12 scenarios? Oh, well, in scenarios 9 and 10, that power went pretty high relative. Oh, well, that happens to be the two scenarios in which I put in a larger pump. I set a pump speed, I think, of 120, which is not realistic, but it's a way I am modeling, what if we put a larger pump in? What happens, okay? So anyway, you see, oh, that's how my pump power behaves through the various cases. And I'm just numbering the cases 12, but again, they're just the scenario names up here. Oh, okay, this is interesting. My flow control valve goes to 100% open. That sounds like control valve failure. And if I go into and I check, this is case 5, 1, 2, 3, 4, 5, all tanks off. And I got to run it, sorry. For you guys, I ran it beforehand, but you haven't seen that. Oh no, we did have control valve failure, which means it just popped open as high as possible. So that's 100% open. So you get a little insight there. Oh yeah, and it kind of makes sense. Each of the tanks is off, right? And it can't meet that demand. There's a little more restriction to the flow. The final thing is like, oh, pressure. How is my pressure in my back pressure valve line behaving? So that is, just for context, it is the inlet, so the upstream side of this back pressure line. I want to know, what is my pressure up here? Okay, how is that tracked through time? And it's like, okay, there are points at which it gets really high, but my set point is 35. So anywhere that's really high, but my set point's 35 means that probably has a really fast moving fluid because I'm getting a lot of frictional loss to go from 50 to 35 over 100 feet, right? Down here, it's not meeting my set point of 35, so maybe it's a control valve failure. And guess what it is? We can go back to those scenarios and see that and see, oh, well, it's because no flow is going through there. So of course the back pressure valve fails. There are reasons for it. But up here, similarly, whoa, that is one high pressure, which means it dropped from 65 to 35, right, over 100 feet. What I did too, which is cool, I'm also wanting to plot velocity with it so I can confirm, oh, where there's really high pressure upstream, there's really high velocity. It's 27. Well, this insight now is, oh, maybe we need to rethink how we're going to operate in these positions, or you just decide, no, I don't care, I'm not using a larger pump. So whatever insights you want to pull, you can use Excel kind of in your own way with Fathom output, using Fathom just as a tool, as a solver, and then you do your own analysis, whatever you want. We have many tools in the software. We have our own graphs, we have our own output and visual report, but there are times where you need to do your custom stuff, and that's what the this integration with Excel is helpful for. Hopefully I haven't lost many of you. Well, if I have, it's okay because we're at the end. So really in summary is, the more you know about Excel and the more you can kind of foresee what you need, the better, the more efficiently you will use Fathom in Excel. Instead of doing things manually, use formulas, both importing and exporting. There's a lot of ways to use Excel with Fathom. And I guess one of the other summaries is our help file. So you can learn about importing, because this webinar was extremely fast, kind of to show you what's possible, not necessarily that you are able to do it yet, but help file, import from Excel. What about if I type in Excel export? What happens? Hey, I can see exporting to Excel. Oh, and it gives me, just like importing, a whole topic on how this all works, right? And again, the export manager is where you can get custom with how tables are built and all that. So that's really it for today. You're welcome to contact us with any questions for support or sales, depending on the nature of your query. Call us, and I wish you all the best in leveraging Excel to improve your AFT modeling experience. Thank you all, and have a great rest of your morning, evening, afternoon, what have you, and we'll check in later. Okay, happy engineering. Bye.